Hello, welcome to the stream, or if you watch this on YouTube, welcome to my YouTube channel. My name's Jared. I build Ruby on Rails e-commerce applications at my company Supergood, using a platform called Solidus. This year, I am going through attempting to solve all of the 2021 Advent of Code problems. Apologize for my voice being a little scratchy. I've already done 3 of these today, and on Friday I had our staff party, and when I've had a few drinks, I talk a lot. So I lost my voice. As I mentioned just now, I've done day 10, 11, and 12 today. 10 was the syntax scoring, where we were matching up parentheses. The Dumbo octopus was day 11, where we were calculating their bioluminescent flashes. Day 12 was navigating through some caves. Now we're about to attempt day 13. Got about 2 minutes before it goes live. I don't know what else I have to talk about. I'll be taking tomorrow night off. I'll be back on Tuesday and Wednesday and Thursday and Friday, I think. Then a break on Saturday again. Oh, I am very sore. I ran 11 kilometers earlier today, and my body does not like that I did that. All right, getting ready for the final countdown here. 30 seconds. Guess we can prep my editor here. We always know what we're doing first. All right. Cool. Let's go. Transparent origami. You reach another volcanically active part of the cave. It would be nice if you could do some kind of thermal imaging so you could tell ahead of time which caves are too hot to safely enter. Fortunately, the submarine seems to be equipped with a thermal camera. When you activate it, you are greeted with, "Congratulations on your purchase. To activate this infrared thermal imaging camera system, please enter the code found on page 1 of the manual." Apparently, the elves have never used this feature. To your surprise, you manage to find the manual. As you go to open it, page 1 falls out. It's a large sheet of transparent paper. The transparent paper is marked with random dots and includes instructions on how to fold it up. Your puzzle input. For example, that's something. The first section is a list of dots on the transparent paper. 0, oh no, okay. 0 represents the top left coordinate. The first value, x, increases to the right. The second value, y, increases downwards. So the coordinates 3, 0 is to the right of 0, 0. The coordinate 0, 7 is below 0, 0. The coordinates in this example form the following pattern where hash is a dot on the paper and dot is an empty unmarked position. Then there's a list of fold instructions. Each instruction indicates a line on the transparent paper you want to fold the paper up. For horizontal, y equals lines, or left, up or left. Okay. In this example, the first fold instruction is fold along y equals 7, which designates the line formed by all the positions where y is 7, marked here with a hyphen. Because this is a horizontal line, fold the bottom half up. Some of the dots may end up overlapping after the fold is complete, but dots will never appear exactly on a fold line. The result of doing this fold looks like that. Now only 17 dots are visible. Notice, for example, the 2 dots in the bottom left corner before the transparent paper is folded. After the fold is complete, these dots appear in the top left corner. That one, those 2 end up there. Yep, yeah, that makes sense. Also notice that some dots can end up overlapping. In this case, the dots merge together and become a single dot. The second fold instruction is fold along x equals 5, which indicates this line. Sure. Because this is a vertical line, fold left. The instructions made a square. The transparent paper is pretty big, so for now, focus on just completing the first fold. After the first fold in the example above, 17 dots are visible. Dots that end up overlapping after the fold is completed count as a single dot. How many dots are visible after completing just the first fold instruction on your transparent paper? Well, on the one hand, I feel like this puzzle has a very obvious next step. I was talking to my friend Adam about speculating about next steps because as a Agile developer, I try to avoid doing that. But in these puzzles, it can be helpful. Well, that's fun. All right, let's, well, I never grabbed our input. So this is our test input. Pop that in there. Oh, I am very sore. I need an Advil or something here. That was 17, right? Yeah, 17 dots. All right. So now let's look at this puzzle here. So we need to create a structure to hold the dots and then come up with some reasonable way to mutate it. I am going to use a hash where the keys are XY pairs. No, why would I do that? I don't need that. I can just put them in a, how would I use a hash? Just array. Just use an array. So I'm gonna write this the way I want to do it. Okay, so we're going to make a paper. It's going to be paper.new with, so we have 2 sort of chunks of this input. We have dots, we have folds, and we can get that by splitting this along the double new line. Splat that out. Construct the dots. I'll just do the parsing in here. So we'll take this, we'll split it on new lines, and we'll map the resulting dots, split those on commas, and convert them to integers. Okay, and I forgot to close paren. And then our folds. Going to be something. So it's folds, split those on new lines as well. And I don't know. Do something. We'll do it after. Let's write this paper thing. Paper. Class takes dots. The dog has joined me. Roxy, what are you doing? Come here. What are you doing? Well, I'll have to get a dog cam eventually. Oh, just missed her. Just missed her. So what do we want to do with this? I mean, to get us... So what do we want to do? We want to take our paper and fold it along x equals 7 for this example. We'll just ignore parsing. We'll worry about that later. And then paper dots dot count. Find out the input for this one is not prohibitively large. That's fine. So how does this work? Oh, it's y equals 7, not x equals 7. Come on, chat. So we need to implement so no, we've done something horribly wrong. I put these kind of guardrails in because I don't trust myself not to make mistakes. All right, so all of the ones that have a y value that is greater than so I think we can do this. So we go self.class.new, and we want to go dots.map dot and if so we return dot if dot last is less than y, right? That's how we decided this worked. Double check. 610 is 1, 2, 3, sorry, 1, 2, 3, 4, sorry, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. So we're interpreting the coordinates correctly. That's cool. Otherwise, we need to fold this dot. And how do we do that transposition? So if y equals 7 and the dot's at line 10, then it should end up 3 back from line 7. So we need the difference and subtract it from the fold line. So it's as we return dot at first, and then dot last minus y gets us the distance that it should be from the fold line. So it's y minus dot, does that make sense? Y, which is the same as that, right? Whoops, that. I'm gonna leave it as is because it makes more sense, but I mean, is that all we need to do? Does this work? No, we get 18. Ah, yes. Because we need to only work with unique values. Okay. If y, we do this, else we do this, but slightly different. I think this becomes x minus dot first minus x. This is just y. This is x. This is first. That might be right. Okay, and of course my actual puzzle is going to have a x fold, so testing that y is working is not going to help me too much. So I just need to actually parse these folds. I'm just going to let my debugger help me with that one. And I am going to not use both block syntaxes in one block, just one at a time. So fold along x, y equals some digits. Oh, I need the digits too. I don't know what to call that variable. That'll get me what I need. And if I don't know what to name the variables, so we're going to map this to axis Z. Terrible naming. Do paper folds first if let's use a case when this folds first. When x will do one thing, when y do another thing, else will be like what? Actually, we can even Oh, this got to be 2i. Let's see. We get 18. Well, that's suspect. Oh, and that's because we didn't actually assign that. Okay. Let's see if we got it right. Not the right answer. Sad. Just take a look, make sure everything parsed correctly here. So we've got our folds. Our first fold is x at 655. That is right. Paper. There's lots of values in it. Broadly speaking, they all look right. Yeah, I'm seeing the same values. I wouldn't expect that to be wrong. Excuse me. All right. Turn the dot if it's less than x, otherwise. Oh, wait, what? What is this? That's supposed to be dot last. Let's see, we'll try. I only got the one. There we go. Okay. So we were just mangling things there. That's cool. Let's remove that binding.pry. See what wrench they throw into part 2, because we're just supposed to do the rest of the folds. Day 13, part 1. Finish folding the transparent paper according to the instructions. The manual says the code is always 8 capital letters. What code do you use to activate the infrared thermal imaging camera system? All right. So then we're gonna have to be able to print it out as well. So that's fine. Not super useful to use a spec here. Just going to open day 13, part 2. And so in our previous one, we all we did in our solution was fold it based on the first fold. Now we want to do all the folds. And we're going to need to print this thing out and read it. So print, paper.print. This becomes f dot first. These folds become f dot last. And if I try and solve part 2 now, I get print no method error. Excellent, that's what I want to see. So let's just print this thing out. What do we do? How do we print things out? I've used a data structure that is not amenable to printing, so this needs to be transformed so that we can print it. Or maybe it doesn't. It's not that many dots. Only a few hundred. So like we can just look up to see whether they're there as we go. So we'll need to go from 0 to the biggest y value we've got. So dots dot map last dot max or something. Each do row and then I guess I should use y here. I'm gonna confuse myself if I use other naming. And then 0 from dots to first dot max. Sorry, I did something weird here. That's x, and let's just print xy here, see if we're on the right track. Seems conceivable that that would be true. Seems a little small, but print. So if dots dot include xy, then we want to print a dot, otherwise, or sorry, we want to print a hash, otherwise we want to print dot. And I want to print a new line. Like that. And then that's include with a question mark. Print, so what do I do it here? Like something like that. No, that's probably not right. Oh, sure, it works. Nailed it. In fact, we don't even need those dots to read this. It just makes it harder to read. RPCKFBLR. 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 Cool. That was fun. I enjoyed that one. Time for some apple cider. A game of gin rummy. Go to bed. For Advent of Code puzzles, a long run. It's a very tiring day. I will not be on tomorrow. I have a prior engagement. But I'll be back Tuesday, Wednesday, Thursday, Friday. As far as I know. No promises, but I should be. So thanks for coming out, and catch you next time.